Welcome back everybody. We're going to take a look at Booklet E, some algebra stuff. I'm going to do this slightly differently. I'm a little bit more zoomed in than the other videos, so hopefully you can see the questions as well. But I'm going to give you a little tutorial on it before we start. So we'll come away from the booklet a second and talk through different types of questions and what they mean, okay? We're going to start with expanding brackets, okay? We should all be aware of what that means. Just multiplying out brackets, removing brackets, okay? I want to look at the difference between the top one and the second one. What we've got in the top one is a single bracket followed by a single bracket, not a double bracket. So what I'd be looking to do, in fact I probably need to put a number there, let's put a 4 there, should we say. I'd be looking to do 4 times that and 4 times that. Expand that single bracket, and then interestingly here, minus x, really important, minus x times that and minus x times that, okay? Really quickly, 4 times 3x, 12x, not a problem. 4 times 2, 8. I picked this example. I would try and do numbers, letters and signs separately. So there isn't a number here, but sort of think of it as 1 times 2, which is 2. X times x, which is x squared. Then the sign, that's negative, that's positive. I've got a minus times and a plus, so that's minus. And the last one, x times 3 is 3x. But this time, it's a negative times in a negative, making that positive. It'll often ask you to expand, then simplify. If you're simplifying, just be careful here. X squareds are different terms to x's, which again are different to numbers. So the only terms that can come together here are the 12x plus 3x. So in your answer, I'd expect you to do 12 out of 3, which is 15x. Compare that to expanding double brackets, 2 brackets next to each other. And then we'd be using our smiley face. Some of you know it as FOIL. If you don't know what I'm talking about, don't worry, okay? 3 times 2 is 6, x times x, x squared. 2 times 3 is 6, positive times negative, minus. 2 times 2x is 4x, positive times positive, positive. And 3 times 3x is 9x, positive times in a negative, it's negative. Again here, x squared term, number term, but at the end here, a couple of x terms that can be brought together. Plus 4x, take away 9x. Think about a number line. Start at 4, take away 9, you go down to minus 5x. Now a little bit on solving equations and rearranging formulas. Same sort of thing. We're trying to get x equals, or if we're rearranging formula, whatever letter they're interested in, that equals something. So it's all about moving things over the equals to get what we want, okay? So the reason I picked these 2 examples as well, I just want you to be happy about making the subject term, or the letter you want to find, that has got to be positive. So here, if I'm going to solve this, I've got 4x here and 9x here. Now forget the numbers, I've got 2 options. I can bring the 9x over with the 4x, and it would be 4x minus 9x. Don't like it. 4 take away 9 is minus 5. Alternative number 2 is to take the 4x over with the 9x. 9 take away 4, I'm a lot happier. So that's kind of made my mind up for me. You go over with the 9x there, and therefore my numbers are being collected this side. Quite simply, the 7 has been left. I need to add 23 to that, okay? And then 9x, the plus 4x there goes over as minus 4x, leaves me with 30 equals 5x. 30 divided by 5, so x is 6. I'm not finishing that off, okay? This time, I'm going to rearrange the formula, okay? But I'm going to try and make x the subject. The reason I've picked x is because I don't like the fact that it's negative. Okay, before I start. So before I even think about moving anything else, my first goal here is move him over the equals, make him positive, make that subject positive, okay? I guess in this case we could jump a couple of steps ahead and say, well, if he is going over there, everything else needs to come in the other direction. So the 8 doesn't move. The minus 4 is over as plus 4. The plus f over as minus f, and this minus 6x is gone over the other side as positive 6x, okay? The opposite of times in by 6 is to divide by 6, but the other thing I can be looking to do here is simplify this. 8 add 4 is 12, so 12 minus f divided by 6 equals x. A little bit of rules of indices, okay? There are 3 rules here. We know a lot harder rules than this. We did them in the number booklet, okay? We know things like how to deal with fractional indices and negative indices and zero indices and things like that. But the ones that are mostly associated with algebra, I would say, okay, well, let's have a look at them, are as follows. So the first rule I want to look at is the multiplication rule. If you multiply two of the same letter with different indices, we can add the indices together. Okay, numbers, same rules apply. We can just do that as 6 times 3. So in this case, 6, apologies, that's moving around a bit. 6 times 3 is 18. F to the power 3 times f to the power 7, add the indices, f to the power 10. Dividing, 6 divided by 2 is 3. F to the power 8 divided by f to the power 3. The division rule is, if you divide in the same letter, you take away or subtract the indices. So it becomes 3 to the power, 3f to the power 5. Don't want to make too many mistakes. And then the last one, a little bit unusual, but it is one you've seen before. If you've got a bracket raised to a power, everything inside that bracket, in this case, gets cubed. Okay, 6 cubed, to put myself under pressure here, is 6 times 6, which is 36, times 6 again, which I'm hoping is 216, correct me if I'm wrong. F squared cubed, okay, we can multiply these indices, 2 times 3, so it becomes f to the power 6. And think about this g as g to the power 1. Okay, so this time we're doing 1 times 3, so it becomes g cubed. So 6 cubed, f squared cubed, and g to the power 1 cubed, giving you that answer. And let me zoom in. Okay, hopefully that's coming into Zoom now. There we go. We're going to quickly then, just before we get into the booklet, we're going to look at factorising. Okay, 4 types of factorising. Now, the way we decide which one to use, we'll use a process of elimination. But let's talk about what they are first of all, okay? So I've got type 1, when I put things into one bracket here. So I'm looking for what number goes into both these and what letter, is there anything else I can take out? So here he'd become 3x. 3 is the highest common factor of 3 and 15, and that's x times x, that's x. So we can take an x out as well, leaving me with x plus 5. It's one bracket factorising. Then we've got the difference of 2 squares. Something squared, in this case d squared, or d times d. Then here comes your difference, minus, right? And this guy, a bit more unusual. What's being squared there? Well, the 4 is 2 times 2, and the c squared is c times c. So what that actually is 2c times 2c. And the rule is, for the difference of 2 squares, that we take what's being squared there, and we take what's being squared there, and we add them in the first bracket. And we take them away in the second bracket. So that factorises to d plus 2c, d minus 2c. I'm not going to do, or I will do examples of type 3 and type 4, I'll do them later, but just to explain the difference. Type 3 is where we have a quadratic equation. X squareds, x's, and numbers. Okay, can't be done with one bracket because there's nothing that can be taken out, no letter that goes into all of those and no number that will go into all of those. So we'll talk about how we do that in a minute. I call this quadratic easy because there's no number in front of the x squared. Well, there's a 1. Okay, so we've got 1 x squared, as opposed to quadratic hard, which is type 4, where it's the same thing, it's a quadratic equation, but this time we've got a number there in front of the x squared, 2x squared, 3x squared, 4, 5x squared, whatever they want to do. Now, what I would do if the question asked me to factorise, okay, I would work backwards, eliminating them all. So ask yourself the question, and I will do this a couple of times in the booklet, is what I'm factorising a quadratic? Okay, if it is, does it have a number in front of the x squared? If it does, this is the method I'll employ, and I'll show you an example of it in a second. Is it a quadratic without a number in front of the x squared? If it is, this is the method I'll employ, and I'll show you that in a second. If it isn't a quadratic equation, possibly it's one of these hidden difference of 2 squares. Is it something squared, take away something squared? Okay, like this one. If so, it's going to end up being a double bracket, okay? But there's that little shortcut to get there that we'll talk about when we get into the booklet. My final thing is, if it's not a quadratic and it's not a difference of 2 squares, okay, then the chances are it will go into a single bracket that is type 1. this guy here almost looks a little bit like a quadratic, but he's missing that number on the end, so he's not, therefore he's a single bracket factorising. Okay, again, we'll come on to examples of type 3 and type 4 in a second. Let's get into the booklet for the next 5 to 10 minutes. Okay, a lot of this I'm going to let you work through by yourself. Let's bring things into view. There you go. Okay, top of page 1. Nothing much to say about this question. It's 2 single brackets, so I've expanded that single bracket there and I've expanded that single bracket there. Be careful that what's before that bracket is -3, so it's -3 times that, -3 times that, and -3 times that. Might throw up some problems with minuses times in minuses, or minuses times in pluses, okay? Expanded on that row, check you're okay, and then simplified there. I've left this one blank to just do for you, okay? Solve 22 minus f divided by 3 equals 6, all right? The reason I've left it, a couple of reasons. First of all, because all of that is divided by 3, the opposite of everything there divided by 3 is to take that divided by 3 up there and times everything there by 3. Well, in this case, it's only a 6, so I end up with 22 minus f equals 6 times 3, which is 18. But I don't like it because that's negative, and we've talked about that already. So my plan here is to move u over to become positive and move u in the other direction. I'm left with 22 minus 18 equals f, so 4 equals f. I just want to quickly compare that with my own question here, okay? This time, not everything is divided by 3, it's just the f. It's almost like this one is loose this time, it's not part of this division. So I probably do this in a slightly different way, okay? You can't move the divide by 3 first here. You have to remove the loose number, so the 22 would go over to be negative 22. You're left with minus f over 3 equals 6 plus 22, which is 28. That's a complete lie. This video's going well, isn't it? Because what should the plus 22 have become over this side? It should have become minus 22. 6 take away 22 is minus 16. My apologies. Now I move the divide by 3 in this case. The divide by 3 goes up and becomes a times by 3. Okay, minus 16 times 3 is minus 48. Again, I've got this problem though, that what I've left is minus f, and I got rid of that quite soon up here, but this I've kind of left it to the end here. Now, one way to think about this is, to make u positive, you need to move over there. But if that's what's happening, you're coming over there, so you're left with 48 equals f. In other words, if minus f is minus 48, then f is 48. Okay, looking at this one, we're now asked to factorise. Okay, let's move that up a bit. Okay, these ones in here. We're asked to factorise. Is it a quadratic? No. Is it a difference of 2 squares? No. That's positive. That's one, and that's not a square number there. So it's got to be a 1 bracketer. Job done. Make sure you're happy with it. Okay. Changing the subject of the formula, not so bad because the 6m is positive. So just a little bit of rearranging there. Plus 7 goes over and divide by 6 again. And again here, has the look of a quadratic, but doesn't have the number on the end. 6x squared minus 12x. So it's not a quadratic. It's not a difference of 2 squares because 6 is not a square number and 12 is not a square number. So we're looking at a 1 bracketer, and there it is. On to the next page. Again, hopefully you can see that. Expanding a single bracket there, nothing to say about that. Changing the subject of the formula, make the subject positive, so it's minus 3g, but it's g I want to be the subject, so we're going to move that to begin with to become positive, everything else in the other direction. Solve this, okay, just think of the inequality sign, this less than sign as an equals. What you end up with is, if you move the minus 3 over as plus 3, 29 plus 3 is 32, and then divide by the 7. If you get something like that, like x equals, or in this case x is less than 32 over 7, don't be tempted to try and work that out without a calculator. Okay, just leave it as a fraction. 32 over 7. 7 doesn't go into 32, we can leave that as we are. If it is an inequality, it allows the examiner to move on to a part B, which can say, okay, knowing that x is less than 32 over 7, what's the biggest integer, the greatest integer that x can be? Well, x can be anything less than 32 over 7. Now, in my mind, 32 divided by 7 is between 4 and 5, 4 point something. So if I'm less than 4 point something, the biggest whole number I can be is 4. Okay. This one here, we're talking about forming an equation. So we're not given an equation like we are here to actually solve. We're being given some information to allow us to make an equation, then we can go on and solve it. So let's have a look at it. Okay, so what we're told is the surface area of a cuboid is 142 centimeters squared, but we're given the three sides, the height, the length, and the width. It doesn't really matter which way around they are. Okay, I've looked at the area of each face separately. So this would be 7 times x, 7x. This would be 5 times x, 5x. And the top would be 7 times 5, which is 35. You may have those in a different order to me. But there's 2 of these faces, 2 of these, and 2 of these. So my equation would be 14x, double that, front and back, plus 10x, double that, plus 70 equals 142. Numbers on this side, simplify this, 24x equals 142, take away 70, which is 72, and 72 divided by 24 gives us x equals 3. Form the equation, solve the equation. Okay, 2 more examples of that for you to look at. Again, I'm not going to go through them, just to mention what allowed us to form the equation here is that we had an isosceles triangle. So these two angles were equal. So I've just written this equals this. There's my equation made, and I've gone ahead and solved it. Okay. Once I know what x is, it's allowed me then to find the sides of these angles. Unfortunately, these have both come out to be 65, which is what I would have hoped that they'd be the same. 65 add 65 is 130. So this guy up here must be 50. To make the triangle add up to 180. Another example at the bottom. Slight difference to the top one. This time I'm not looking at equal angles, I'm looking at all 3 angles and what they add up to. Angles in a triangle add up to 180. I'll put it there. So this equals 180, and that's exactly what I've done there. Check that makes sense to you. And you might want to pause and kind of have a go at that one. Okay. Again, I'm not going to say too much about these. A 1 bracket factorising, again, not a quadratic, not a difference of 2 squares, just 1 bracket. Or compared to a double bracket expanding using foil or smiley face. Rearranging the formula. Okay, I haven't filled these in, let's have a look at them. It's a bit of rules of indices again. So 6 times 3 is 18. P to the power 6 times p cubed. Add the little numbers. Add the indices, 6 add 3 is 9, so I get 18p to the power 9. This one, 3.4 divided by 13.6, don't like that. However, we may have spotted, I guess, that goes into that 4 times, so it simplifies to 1 over 4. However, what would have been more of a giveaway, I guess, is the indice, the 8 divided by the 2. G to the power 8 divided by g to the power 2. Take them away, 8 equates to 6. So I'm looking for something with a power 6. So it can't be that or that. So I'm asked, look, hopefully it's quite simple to you. Is 3.4 divided by 13.6 a quarter? Alright. Is it 4 or is it 0.4? Well, in this case it's a quarter, okay? A little bit tricky, I suppose. M cubed times m to the power 6, add the little numbers, 3 add 6 is 9, but then when we divide by m to the power 9, 9 take away 9 is 0, so we'd be left with m to the power 0, but anything to the power 0 is 1, and then that final rule, that kind of bracket to the power rule, 3 cubed is 27, a cubed is literally a cubed, and b to the power 7 cubed, 7 times 3 is 21. Okay. Unfortunately, we're going to have to do this in 3 parts. So we're going to come to the end. At the end of this page, take a look at the top ones. Pause now if you want to. Nothing different on that page to talk about. And take a look at the bottom ones. Again, not an awful lot to say about that. Bro, we're going to pick up on the next page in the next video and do a lot more factorising in that, but hopefully that kind of little tutorial will help you going forward. See you!